Okay. So I want to show you an example with a function call, right? So go ahead and make a file called example program 3.c or whatever you want to call it. Oops, I don't have mousepad. Okay. Keep forgetting what operating or what computer I'm on. So I'm just gonna make a function called int add. It's gonna take a int a, and you know what? I'll make it a little interesting. Maybe we'll do unsigned int a and unsigned, or maybe I'll do assigned int b as an argument, right? No reason to do this. You would probably never do this. Just something to do, you know. And I'm gonna say result is gonna be a plus b. Sorry, you want to say just int result is equal to a plus b, and we're gonna return that result, right? And go ahead and close that. And then in the main function, just go on ahead and declare two. You know, for the sake of this video, I won't declare the two variables. I'll just pass in the what's it called? We'll just pass in the arguments. So I'll pass in 5 and -1, and then I'm just gonna printf func call. Oh shit! What the fuck? Okay. Forgot my format specifier. Yikes. Okay. End line. And let me make this void again because I don't want to actually return any value. This will show us our return. So this is kind of a function call and return video, I guess. I'll do probably do another function call video in another video. Okay. So go ahead and just compile that. Oh my god, what am I doing? That's that's crazy. Okay. Oh my god, that's fucking insane. Okay. Wow. Oh my god. So what happens when you just wake up? Actually, I woke up like an hour ago. Include sdio.h. Okay. Save that. Send this out. What am I doing? There you go. Okay. So if I run this program, I should get 4 as a result. Out. Yep. See, I got 4. Oh, and by the way, if you don't know what an unsigned int is, because again, I know a lot of people don't actually program in C. I mean, hell, I was coding in C++ for like a few months before I ever actually coded and ever used C. Not much of a difference, but just simple stupid things. Like there's no booleans in C. So unsigned int versus signed int. Basically, a signed integer is a negative from negative to positive range, right? And there's obviously a smaller positive range and a smaller negative range as a factor. But an unsigned int, there's a larger positive range, and it's only positive numbers, right? And I want to just show what this looks like in GDB, right? I'm actually discussing. Alright, so just go ahead and do gdb a.out. Don't do that. Quit. And do gdb a.out. And I'm just going to set disassembly flavor intel. I'm going to disassemble main. You know, maybe I should cover this in... Nah. I'll probably just do, I'll cover some stuff right now, and then I'll pause the video, and then I'll come back. So just your function prolog, pretty basic stuff. Allocate. Wait, I forgot. What is, it's like 16, I think. Even I forget sometimes. Yeah, it's 16. So we allocate 16 bytes on the stack. Okay, anyway, so we allocate 60 bytes on the stack. So I'm going to disassemble main, and we are currently at the 17D instruction, right? So I typed start and I clicked NI until I got to 17D, and now I am right at the function call. So now I want to evaluate something. I want to evaluate the value stored in the source register, the ESI, right? The source register. Um, so if I do P ESI, you will see that's -1, right? If you remember in my function call in the C program, I passed in -1, right? So again, it's backwards, right? In the source code, I actually pass in 5 first, right? And then -1. But in assembly, -1 is passed first, and then 5. So this is something you have to keep account of. Like the ordering of things, it happens backwards. And you just have to keep account of that in the real reverse engineering scenario. So this value 0x a bunch of f's is actually equal to -1, right? So negative numbers aren't represented as as like 0x -5, right? They're represented like this. So you should be able to differentiate, like, okay, this is probably going to be a negative number. This is a number. Um, but typically, what is it called? You can generally tell when there's a function call because the add function is being called, and then we're moving something into the source register, and then we're moving something in the destination register, right? And these are typically used for function calls. And then if I do p edi, you'll see that obviously holds 5. I passed in 5 in the source code, and then we call the add function, right? So now you can actually disassemble the add function also. So now you can look in the add function. Now, how do we know, looking at this, that these are not variables, right? Because if you remember from like 2-3 videos ago, we were passing things into um, EAX, right? So, but in this case, we're moving EDI into um, RBP minus 0x14 offset. Now 0x14 in decimal, yeah, I was right, and I didn't say it out loud. That sucks. Okay, so it's 20, right? And 18 is whatever, it's 24. So this is moving it into 20th empty space. This is moving into 24th empty space. That's not important, right? We understand offsets. Or at least I hope you do. If not, you should watch more videos. So whenever you see a register EDI being passed into some empty space on the stack frame of a function, that is a function argument, right? So you see ESI. So you should immediately know, because we've never used these registers before in the add function, right? But suddenly they're being used to move something into an empty space. So that's how you know it's a function call. And then that value is moved into EDX, so the function parameter argument is moved into EDX, moved into EAX, they are added, we move EAX into the first empty space on the stack frame, and then we move that value into EAX, and then pop RBP. So I'll explain that. So I mean not I mean sorry, I won't explain that. This just pops the old value of RBP back onto the or it returns, oh my god, what am I saying? It literally fetches the old value of RBP and puts it into RBP. Okay, Jesus, what am I saying? So this just restores the old value of RBP. I can't believe I struggle with that. Anyways, and then the return function and the return instruction is called. So basically, when at the end of a function, whenever you see something being moved into EAX, right? So as you can see here, this could be something different. This could be EBX, right? It doesn't matter. But at the end of a function, when you see something being moved into EAX, that will be the return value, right? So that's the return value in this case because because the last thing that's being moved to is EAX, and then the return instruction is called, which just returns to here, right? So let me think. What else should I cover? What else should I cover? So let me do NI again, and I should be at. Let me actually disassemble main again. Let me clear screen, and then disassemble main. All right, I'm here now. So I'm after the add function, and EAX that's moved into here, right? So if EAX is used as as the return value, it should also make sense that the call function puts that result into EAX. At least I hope so. So after a function call, whenever you see EAX, it's usually EAX. Okay, but it could be something different, but it's usually EAX. When you see EAX, when you see the value of EAX being moved into the empty space of a stack frame, that's how you know that this EAX register is the result of the call function. So that's moved into the first empty space, and then that empty space is again moved to EAX, and then EAX is moved into the source register, and then your format string buffer, or sorry, your format string memory address is moved to REX, REX moves to RDI, and the printf function is called. So let's try to compare that with here. So I covered the main function, I covered the add function, so I will skip that. But if you remember, okay, my bad, I just spat out more water than a dolphin. Anyways, so if you remember, in our main function, we defined a integer func call, and we equated that to the function call add with two values passed into it, right? So if you remember, everything actually happens backwards. Sort of. It's not like that, but it kind of happens backwards. So function call, right? Function call, the arguments pass into the function call. Anyways, return value EAX is passed into the word pointer. Now I'm at this instruction after that return value has been passed, right? So if you look at x/dw, you have to do dw because this is a d word, right? So it's a double word, you kind of have to do that. And we look at that offset, as you can see, the return value should be 4, right? Obviously, so the return value is 4, and that's moved into our first empty space on the stack frame. And then if we actually look at what's it called, the value stored in EAX. So let me do info registers EAX, right? You see that is 4. So that is our return value. And then that return value is moved into ESI, and then the printf is called. So again, you see how you have to kind of get used to the flow of the program. We have function arguments. So in our source code, when we're looking at this with our eyes, right, with our human eyes, it's int func call first is equal to this. So you would assume that in assembly we would have this declared first, and then we would have the function call, right? But that's just not how it works here. I will do a scenario. Okay, I will not be doing any scenarios. I completely forgot that. So go ahead and clear your screen and then do continue. And I'm just going to step through this program one more time and quickly explain it, right? Just to summarize everything up. I'm going to do start. And then I'm going to go ahead and disassemble main. Then I'm going to, so function prolog, space allocation, -1 into ESI, 5 into EDI. That's how you know these are function arguments. The function is called. So now I'm going to NI until I get to the function call. So where is that? 178. I should go one more. 17D. And I'm going to go one more to go after the function call. So the function call is finished now. And I'm going to go ahead and disassemble the add function. So the EDI and ESI registers are used to move into an empty space on the stack frame. That's how you know these are function parameters, because again, there is EDI and ESI, right? and that's moved into two empty spaces, and then these are moved into the EDX and EAX register. And also, something else you might see is that the EDX and EAX register work together a lot in addition, multiplication, and subtraction. So typically when there's any of these arithmetic operations happening, they will typically be moved into EDX and EAX, and then that operation will be performed and it will be stored in EAX. However, division is stored in EDX, but I will cover that later. That's not important right now. So that value is stored in EAX, so that's moved into an empty space on our stack frame. And then that's moved again into EAX, and then the return value is called. So this might be a little confusing because we have these what's it called? We have EDI and ESI, and then they're moved into empty spaces, right? And you're probably wondering where is result? Don't worry, I actually had this problem a while back. I had no idea how the fuck this worked, but what's it called? That's actually moved right here into the empty space, right? So that would be result. So whenever you see a big offset from your base pointer, right? So this is what 20, right? This is something, doesn't matter, right? Whenever you see a big offset like that, that is typically your function parameters, right? Because they're all the way down there. And then what's it called? They're moved into registers and added. But whenever you see a small offset like this in your function, that is typically a variable. So this would be result, right? That's moved into result, okay? That's moved back into EAX and then returned. So that's something to keep note of. And then I'm going to do NI again, and then I'm just going to disassemble main to see where we are. Disassemble main. Let's see where am I? I'm at 185. So we know, I already checked this out. We know these hold the value 4. That's moved into ESI. Let's see, where am I? I'm at 18A. I'll just keep going until it prints. And you don't have to keep typing it, actually. You can just do space. You can spam spaces. And then that value is printed. So if you're confused, you should check this out on your own. Write this program yourself and then check it out yourself.